Split tunneling with VPNs. VPN tunnels are terrific. They're fantastic for remote access users like, for example, Bob. He wants to access this server, but he's on the internet. How does he do it securely? He establishes a VPN tunnel to a VPN gateway, such as an adaptive security appliance, and then he has access to the internal resources. The benefit of this VPN tunnel is threefold. Number one, we're only going to set up the tunnel for people we trust. So we have authentication. We're going to make sure the data doesn't get manipulated in transit. That's data integrity. And due to encryption, we're going to make sure that data is protected. So anybody eavesdropping on the internet won't be able to make sense of the packets that we're sending across, but still we allow Bob to communicate with these internal resources. One of the default consequences of using a full tunnel is that all packets sent by this user are going to go through that tunnel. So if Bob's going to this server, that's perfect. The traffic goes through the tunnel, hits the ASA, who decrypts the traffic, sends it over to the server. But what if Bob's trying to go out to cbtnuggets.com or some other server on the internet? What happens then? Well, by default, all that traffic also would need to go through the tunnel. And then if we train the ASA to redirect that out to the internet with doing some NAT, we could as well. But that's a lot of overhead. If our security policy allows it, we can implement something called a split tunneling policy, and it's really simple. And here's what we do. We have our VPN tunnel established, but we train the VPN that only traffic destined for this network, as an example, should go through the tunnel, and all other traffic can go free and unencrypted and not through the tunnel out to resources like CNN or CBT Nuggets, etc. And that's the whole concept of split tunneling. Only tunnel some of your traffic, maybe based on the destination of 10.0.0, and let everything else that's not destined to 10.0.0 simply go free and clear. Our next question is, why exactly would we set up split tunneling? Why would we tell this VPN client to only send traffic for the 10 network over the tunnel and send everything else in the free? One big reason is overhead on this ASA right here. For example, let's say Bob, the user, is streaming a sporting event. So he goes out to a website and he's doing a live stream or near live stream from that web server. If he does it through the tunnel, the ASA is going to have to do this. For every packet that goes to Bob, the traffic from the server is going to go, let's say this is our server right here, server 1. The traffic would have to go to the ASA. The ASA would have to encrypt the traffic, send it to Bob through the tunnel just so Bob could get it. Now, if there's hundreds of clients or thousands of clients all doing that, the overhead and the bandwidth utilization on that outside interface may just be too great to allow full tunneling. So that'd be one of the reasons we do split tunneling, is to lessen the overhead on the ASA itself. At the client, before we implement a split tunneling policy, it would look something like this. The user would be able to go to the internet just as they normally would, and for example, we'll go to google.com networks, no problem. Once they connect to the VPN and will authenticate, once they connect, they can then go ahead and go to internal resources, like a server on the inside, maybe at 10.0.0.5, which is an internal server, but they can no longer go out to an external resource. And it simply won't work because the NAT and the hairpin turn on the outside interface of the ASA isn't set up for that yet. So to fix this, we could implement a split tunneling policy. From the user perspective also, if we open up the details of the VPN client and go to route details, it also indicates that we have a full tunnel policy because it says we're going to secure all traffic. That 0.0.0/0, all traffic's going through the tunnel. To fix this, we're going to go ahead and close our VPN session, disconnect it. We'll go to the ASDM and we'll implement the policy for this group that says that we want to implement split tunneling. Inside of ASDM, we'd go to the group that that user is associated with and we'd modify the properties of that group. Under Advanced and Split Tunneling Policy, this is where we would tell the ASA that we want to implement a split tunneling policy. We do that by selecting tunnel just the networks in the list below, and then either create or point to a standard access list that points just to the networks that you want the tunneling to happen for. I just so happen to have one called just 10. It is a standard access list that points to the 10.0.0.0 network/24. We'll click OK, we'll apply that change, and then we'll go back to the client. Back at the client, we'll go ahead and we'll launch the VPN client again. And once we're in, the tunnel is established. We should now be able to go to internal resources. Let me go ahead and hit refresh a few times there. And if we now go back to Google and hit refresh there, that should work as well. Or we could go to cisco.com or any other resource that was available on the internet. If we go back to the client to look at the details of that as well, by clicking on the VPN icon there, you'll see that the secured routes now indicate that it's just the 10.0.0 network and not all network traffic. So we have implemented, in effect, a split tunneling policy for this group, which this user is a member of. We can use the command line interface or the ASDM, whichever one we're closest to verify the details of our existing connections for VPN. In this case, we're using this show command here. It says we have this user who's connected. We've given him this virtual IP address for the duration of his connection. He's a member of this group, and he came in on this connection profile. It's on the group itself where we implemented the split tunneling policy that makes it possible for that user to tunnel traffic just to the 10 network over the VPN tunnel, and everything else is free to go as it normally would out of his interface card to his default router and off to the internet. In this MicroNugget, we've identified what split tunneling is, why we would do it, and how to implement it and verify it on the ASA. I hope this has been informative for you, and I'd like to thank you for viewing.